In this video, we will be discussing conic sections, Objective 5.3.1, identifying the equation of a parabola in standard form with a given focus and directrix. We will look at several variations of solving problems related to parabolas. A parabola is generated when a plane intersects a cone parallel to the generating line. In this case, the plane intersects only one of the naps of the cones. Here you see a double cone. Each of the cones are called naps, and in the top of this graphic you can see a plane, almost like a sheet of glass, intersecting the nap of the cone, creating the parabola. A parabola can also be defined in terms of distances. As we consider a parabola, we want to recognize that it is the set of all points whose distance from a fixed point, called the focus, is equal to the distance from a fixed line, called the directrix. The point halfway between the focus and the directrix is called the vertex of the parabola. In solving problems related to parabolas, you will be locating the vertex, the directrix, and the focus. On this slide, you will see the standard form for parabolas that are oriented vertically and horizontally. When the parabola has the variable x that is squared, that produces a vertical orientation for the parabola, which means that the parabola opens up or opens down depending on the value of p. When the variable y is the variable that is being squared, then you have a parabola that has a horizontal orientation. In that case, the parabola opens right or opens left. The value p that you see in each of these equations represents the distance from the vertex of the parabola to the focus, as well as the distance from the vertex to the line that is the directrix. In the diagram at the bottom of the screen, we see a parabola with vertical orientation opening up. In this example, the vertex is located at the origin 0, 0, which is the simplest type of parabola to deal with. Then the distance p is highlighted with these bracketed marks, showing that if from the vertex you move a distance up p, you locate the focus, which is an ordered pair 0, p, and if you go down that distance p, you get the equation of a horizontal line that is the directrix, y equal -p. In a similar fashion, we would be able to locate a focus and directrix for a parabola that opens right or left. Let's take a look at an example and how to create the graphs, how to find these values and draw the graph of a parabola. Before we do that, just to clarify a few more examples or general explanation, in a parabola with a vertical orientation, the standard form of the parabola has the variable x isolated in a square expression, then that is equal to 4 times p times y minus k. In this scenario, the parabola no longer has a vertex at the origin 0, 0, but rather has a vertex located at the ordered pair hk, where h is located here and k is located here. K is always located with the variable y. H is always in the parentheses with the variable x. If you will notice in these equations, there is a subtraction sign built into the equation. So when you're identifying the value of h and k, you will actually end up taking the opposite sign of what you see. So this is the standard form and the easiest to be able to read off the h, k, and identify the p-values. However, sometimes parabolas are given to you in general form, ax squared plus bx plus cy plus d equals 0. In this instance, you will use completing the square to write the equation in standard form and then proceed from there. So if a problem is given to you in general form, and it frequently is, you must first do completing the square to write it in standard form, then you will be able to identify your vertex. Once you identify your vertex and the value of p, then you're able to locate the focus and the directrix. If the value of p is positive, then the parabola opens up. If the value of p is negative, then the parabola opens down. And remember, p is found from this value in the standard form. Now, if we move on and look at parabolas with a horizontal orientation, things will look very similar. However, you will notice in the general form of the equation, it is the variable y that has been squared. You have a y squared plus bx plus cy plus d equals 0. You will again use completing the square to write in standard form. In the standard form, you can see that the variable y is the expression that is squared, and the variable x is over on the side with the p. Notice that h is still inside the parentheses with the x, and k is still inside the parentheses with the y. And so your vertex is still hk in these scenarios. If p is positive, then the parabola opens to the right, and if p is negative, the parabola opens to the left. And you have the equations for your directrix or your focus in each of those scenarios. Now, considering an example, let's put those things into practice. So this question asks us to put the equation x squared minus 4x minus 8y plus 12 equals 0 into standard form and then graph the resulting parabola. So we will need to do completing the square for this problem. The first step will require that we add 8y and subtract 12 to the other side of the equation. This leaves x squared minus 4x, I'm intentionally leaving a space, equal to 8y minus 12. Now, in the process of completing the square, you will multiply the value of b, which in this case is negative 4, by 1/2. So we will say 1/2 times negative 4 equals negative 2. Then we will take that value, negative 2, and square it, and this value of 4 is the value that we will add to both sides of the equation. So I will add 4 to both sides of the equation. Now we will factor the left side, so that produces x subtract 2 times x subtract 2 equals 8y subtract 8 when we combine like terms with the negative 12 plus 4. X minus 2 times its identical self produces x minus 2 squared, and now on the right hand side of the equation there is a factor of 8 in common that we will factor out, leaving 8 times y minus 1. Now we are in standard form. So this was the first part of the question, to put the equation in standard form. So we have accomplished that. Now we want to identify our vertex and our value of P. Our H will be equal to a positive 2. Remember, because the subtract sign is part of the equation, you choose H to be the opposite sign of what you see. So H will be a positive 2, K will be a positive 1, meaning that our vertex, which is HK, will be equal to 2, 1. Then we'll use this value of 8 to identify P. Remember from the formulas, that number is actually equal to 4P. So 4P is equal to 8. Dividing by 4 on both sides, P will be equal to a positive 2. Since P is positive, the parabola will open up. Because this was quadratic in x, it is a vertical orientation parabola, and since the p-value is positive, that means that it opens up. Now we want to graph the resulting parabola. So we will create an xy axis. We will locate the vertex at 2, 1. Then we will use the value of P to locate the focus and directrix. The focus will be a distance of 2 above the vertex. So in a vertical path, I will move up 2 from the vertex, and that will give me the focus located at 2, 3. Then from the vertex I will go down a distance of 2. Don't forget to count the axis itself as one of those steps. Down a distance of 2, we'll locate the horizontal line y equal -1, which is the directrix of the parabola. Then we will loosely sketch in the shape of the parabola opening upwards. It would probably be a good idea to at least find out, since we're about to cross the y-axis, what the y-intercept would be equal to. The y-intercept, remember, is when x equals 0. So if I substitute that into the original equation, 0 squared minus 4 times 0 minus 8y plus 12 equals 0 means then these go to 0. I could add 8y to the other side. 12 equals 8y. Divide by 8 on both sides, and then reduce. 4 will divide into each of those, so I get y equal to 4 goes into 12 3 times, and 4 goes into 8 2 times. So my y-intercept will actually be at 1.5, which is about right here on my graph, which helps me to better understand how wide I need to make the graph. Since all parabolas are symmetric about their vertex, I can go to a distance of 2 to the right and locate a point also at 1.5 and continue tracing out the shape of my parabola. And so we have located all of the key points for the parabola and sketched the graph of that parabola. Let's try another. This is a more precise looking graph, not in my handwriting. That is the correct answer to that problem. Now, working another example, we will put this equation in standard form and graph the result. The first thing that I will notice, since it is quadratic in the variable y, that means that the parabola has a horizontal orientation. So we will begin to isolate all of the y variables on one side. So I will choose to add x and subtract the 16 to the other side, leaving me with 2y squared plus 12y with a blank equal to x subtract 16 with another blank. Now, in this process of completing the square, this is a great example showing how do you deal with completing the square when the leading coefficient is not a 1. Notice that this has a lead coefficient of 2. So you must first factor that 2 out, leaving y squared plus 6y equal to x minus 16. Now we will proceed with the process of completing the square. We will multiply 1/2 times the v value of 6 produces 3. We will then square that to get a value of 9, and that is the value that we will add on this side. Now be careful, because what we have really added on this side is 9 times this factor of 2. And so what we need in order to maintain equality or a balanced equation is to add the 2 times 9 to the other side. So we are really adding 18 to that equation. Now we can continue to factor the expression on the left. This will be 2y plus 3 times y plus 3 equals x. Combining the negative 16 plus 18 makes 2, which then gives us 2 times y plus 3 squared equals x plus 2. And that is an understood 1 times x plus 2. Finally, we want to get this in standard form, so now we're ready to divide on both sides by 2, which gives us y plus 3 squared equals 1/2 times x plus 2. So now we have the equation in standard form. Be careful, since this has a horizontal orientation, remember that h is the variable that is inside the parentheses with x. Choosing the opposite sign, h will be -2. K is the variable inside the parentheses with y. Choosing the opposite sign, k will be -3. So that tells us that our vertex is at the ordered pair -2, -3, because it is always in the order h, k. Then 4p is equal to this number that is multiplied times the x plus 2. So 4p is equal to 1/2. Solving for p, we will need to multiply on both sides by 1/4. resulting in a p-value of 1/8. Since p is positive, that means that the parabola opens to the right. Now we're ready to sketch the graph of this result. So we will draw an XY axis. We will locate the vertex at -2, -3. Then we will use the value of P, which is 1/8, to go a distance to the right and left of that vertex to locate the focus and the directrix. Keep in mind, since the parabola opens to the right, the focus is always inside the parabola. So when we go the distance of 1/8 to the right, which is a really tiny distance, that will produce our focus. So our focus is going to be at -2 plus the distance of 1/8, comma -3. Getting a common denominator, if you needed to find that, -2 is really -16/8 plus 1/8. So our focus is at -15/8, comma -3. And then our directrix is a distance of 1/8 on the outside of the parabola. So we will need to draw a vertical line. And to find the equation of that vertical line, the equation of a vertical line is always x equal. It is going to be the value of our h, which is -2, minus the 1/8. So that is going to be -16/8 minus 1/8, produces a directrix of x equal -17/8. And then we sketch in the parabola. To get a better idea, we probably need to locate the y-intercepts and the x-intercepts. The x-intercept, we let y be 0, so I will have 2 times 0 squared minus x plus 12 times 0 plus 16 equal to 0. This goes to 0 and this goes to 0. If I add that x to the other side, I get x equal +16. So that is going to be really high up. Like if this is -1, there's my 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Because of my scale, I don't have room to go find, oh, hold on. What did I just do? Wrong way, that's a y value. Sorry about that, guys. 1, 2, 3, 4, 5, 6, 7, 8, 9. Again, same problem. Not enough room, but that tells me that my x-intercept is far out here on the right, so this will be a fairly narrow parabola. Let me go back and find my y-intercepts, where I let the x be 0. So I will get 2y squared minus x that's 0, so that's gone, plus 12y plus 16 equals 0. And I would solve that by the quadratic formula to find my two y-intercepts. So -12 plus or minus the square root of 12 squared minus 4 times 2 times 16 over 2 times 2 is -12 plus or minus, and let's see, let me grab a calculator to make sure that I calculate those values properly. this turns out to be the 12 squared minus 4 times 2 times 16 turns out to be a value of 16. And the square root of 16 is 4. So then we have two things to work. We have negative 12 plus 4 over 4, which is negative 8 over 4, which is negative 2. Kind of draw a dividing line here. And negative 12 subtract 4 over 4 is negative 16 over 4 is negative 4. And so these are my y-intercepts. I have a y-intercept at negative 2 and a y-intercept at negative 4. So we can see that this is a very narrow parabola opening to the right. Now, what happens if you're given certain information and in reverse asked to find the equation of the parabola? So in this scenario, we're given the focus of the parabola and the directrix. Since the directrix, notice that the directrix is a horizontal directrix, this means that the parabola has a vertical orientation. Let's draw the graph of what we have. So if we sketch this graph and we go to 2, 4, 6, 8, if I count by twos, if we go to where we have the horizontal line y equal 8, then we go to the focus of 0, negative 8, negative 2, negative 4, negative 6, negative 8. If this is the focus, what we know is that the vertex is exactly halfway between the focus and the directrix. The value of P is an equal distance above and below the vertex. And so both of these appear to be a distance of 8 from the origin. And so we can show this distance is 8 and this distance is 8. Remember, distance is always positive regardless of the direction you're traveling. And this would tell us that the vertex is at the origin 0, 0. So that is our H and K value. Now, since the focus is always inside the parabola, that means this has to be a parabola opening downward. And if it opens down, that means that P must have been a negative to cause it to open down. So our P must have been a negative 8. So now we're ready to take the standard form of a parabola that has a vertical orientation, which is x minus h squared equals 4p times y minus k, and substitute the h, k, and p that we just determined. H is 0, k is 0, so this will end up being x minus 0 squared equals 4 times the p value of negative 8 times y minus 0. So we end up with x squared equals negative 32y. Or, if we divided by 32 on both sides, we could also say y equals negative 1 over 32 x squared in general form. This concludes our explanation of the conic section parabola.